Hello YouTube. Today I will be giving an example of how to run a package that I wrote called smoothDE. To start with, we'll need to install a package for the scikit-sparse library, and I'll be doing this with the Mac OS requirements, so I'll be doing a brew install of the suite sparse library. If this were Linux, then we would use the lib suite sparse library. Once the scikit-sparse requirements are installed, then installing smoothDE is simple. You just run a pip install for smoothDE, like so. Next I will import some libraries, the first one being matplotlib.pyplot for displaying data, the second library numpy for storing data as matrices and for generating synthetic data, and the third library will be the smoothDE.estimator, and specifically I will be importing the Density Estimator class from that library. With the setup out of the way, let's look at an example problem. And to start off with, I'm going to instantiate the Density Estimator class with arguments of dpow equal to 3. In this case, dpow is going to dictate the derivative used for the smoothing penalty. In this case, 3 means that I'm going to use the square of the third derivative to calculate the smoothing penalty. The second argument I'm going to pass is the area in which I want the algorithm to fit the density. In this case, it's going to be from -5 to 5 along the x-axis and -5 to 5 along the y-axis. And for each of these, I'm going to tell it that I want it to fit it at a grid of 32 points. Next, I'm going to create a data set composed of two Gaussian distributions. The first Gaussian distribution is going to have 30 data points, and the second one is going to have 20 data points. The second Gaussian distribution is also going to have a smaller variance, and it's going to be shifted up and to the right. I wrote smoothDE to mirror the sklearn library. In this case, all we need to do is .fit the data. One of the methods of smoothDE is to predict the probability of an input point or a set of points. Finally, I'm going to plot the contour of the densities with the actual data points overlaid on top in red. To do this, I generate all the pairs of x and y coordinates from -5 to 5 in both the x and y dimensions, and then I flatten them, the x coordinates on top and the y coordinates on bottom. I concatenate them, and then I transpose them. Now I have a grid that's similar to the input training set. I'm going to pass that into smoothDE. As before, I'm going to use the predict probability to convert these coordinates into probabilities, and then I'm going to reshape them back into a two-dimensional matrix of 100 by 99. Oops, fix the color. In this figure, smoothDE's density is shown as the contour, and the actual data points are shown as red points. In summary, smoothDE is a pip installable package that mirrors a lot of the naming conventions of sklearn. And to use it, you need to instantiate it, you need to perform a fit, and then you can use it to make predictions. Thanks, and smooth travels.